lecturers and our friends. Today, our group 6 will present the plagiarism detections in examiners. Let we see our group members first. I am Christopher Won House, and my teammates is Gong Yuhan, Gong Lingji, and Eddie Vies. First, we will look into the case studies and problem recap. Our case study is the plagiarism detections in examiners. Plagiarism issues, as we know, in examiners becomes more serious from time to time. Many of the students eventually is involved in the plagiarism issues by copying and paste others else's words and did not think everything about the assignments. The cause then did not do anything and always wait for the answer for the others. This will cause the thinking skills of the students becomes weaker. They they take the opportunities to get into the plagiarism issues in the assignments. They did not think for something news. They did not gain anything inside the knowledge. It will also affect the overall academic integrities in our countries. For the proper recap, first problem is the students who take part in the plagiarism issues. They did not will gain anything or obtain any knowledge within the whole semesters. They do anything. They do the things, but did not gain anything. Problem two, if the lecturers cannot detect the plagiarism issues inside the assignments as well, the issues will most probably get worse and difficult to cope with. Number three, if the issues becomes a bad culture inside the schools and bringing it inside the schools, it will affect how the students, the mindsets, they will think these ways can be their ways to do the assignments and they will get into the plagiarism issues. This part of me and I will pass the baton to the next presenters, Go Ling Ji.
For the part of algorithm selection, nowadays algorithm plagiarism is a lot of form. Sometimes it's just a copy and paste. Other time is more subtle like rewording, rearranging, or mixing content from multiple sources. Because of this, we need to prepare a lot of different algorithm depending of the what kind of the plagiarism we are trying to catch. First, we have divide and conquer. This not a method, is more to a strategy. It's break large document into smaller part like sentences or paragraph. This make comparison faster and easier, especially for long text. Next is framing cup algorithm. It's use hashing for find exact meshes. Great for spotting copy and paste plagiarism. It's fast and works well with large amount of text. Then we have cosine similarity with TF-IDF, means terms frequency and inverse document frequency. This method look at meaning instead of exact word. It's perfect for finding paraphrase content where someone trying to change the word but keeping the same meaning. Finally, longest common subsequence, or we can call that in LCS, it's find the longest sequence of words that appear in same order, even if there is extra word between them. This help to catch the plagiarism where content is rearranged or disguised.
A very good evening to our lecturer, Dr. Ong, and to my fellow friends. Today, I would like to explain the rationale behind the algorithms that we have chosen for our plagiarism detection system. As you can see, there are five criteria that we follow for our algorithm selection. So, first of all, it's effectiveness for different plagiarism types. Next is efficiency for large scale academic use. Third is flexibility in matching both exact and paraphrase text, which means it's able to identify identical copy as well as text that have been altered for the document. And then this complementarity. Each algorithm addresses a unique angle, which means each algorithm is designed to tackle a different type of problem where maybe it could be related to large amount of documents where you have to scale through one by one, or a small scale document where you can go through it really quickly and identify the pattern. And lastly is real world adaptability. How well can we implement this algorithm into real life situation? So I'm going to start with divide and conquer algorithm, and we chose it because it splits large amount of documents into smaller chunks, make it easy to analyze the pattern one at a time. As for the alternative that we have rejected, it's sequential processing, and it's because it's too slow and not scalable, which means it does not split the large amount of documents into smaller chunks, making it a very slow and arduous process to wait for it to go through all the documents, and it's not scalable, meaning since it's very inefficient, it's not worth trying to make it scalable. Next is the Rabin Cup algorithm. We chose it because it's fast and efficient string matching for exact copying, which means it's able to quickly identify the words that have been copy pasted repeatedly across multiple pages within the document and find the exact match quickly. And the alternatives that we have rejected is brute force matching, which is because it's inefficient at analyzing large data set. Brute force algorithm would be preferable to be used in smaller scale documents, maybe within 50 documents or something, which it can go through pretty quickly. Next is term frequency, inverse document frequency cosine. We chose it because it captures the paraphrase and the semantic similarity, which means it's able to identify which sentences or phrases that have been altered due to paraphrasing, as well as identifying the semantic similarity. The alternative that we have rejected is Jacket keyword overlap because it's too shallow, weak on reworded count. It's not able to keep count on how many words or phrases that has been reworded multiple times, because when you tend to paraphrase a lot of phrases and text, it's very difficult to keep track on how much of them that we have actually paraphrased. The last algorithm is longest common subsequent, LCS. We chose it because it's efficient in detecting reordered or fragmented plagiarism, which means that when you paraphrase sentences, you maybe choose specific paragraphs and within the document, and then you paraphrase it, and then you change the order and alter the sentences, so making it difficult to identify whether it has been plagiarized or not. As the rejected alternatives for this is sequence alignment, for example, like Needleman Wunsch algorithm, because it's too rigid and requires exact position alignment, which means it's reliant on which sentence is aligned with and exactly where it's aligned, and to identify the pattern on how it's altered or paraphrased and so on. That's all. Thank you.
Okay, now for the analysis decisions, and for our input type in our case study, that is the plagiarism detection in the assignments. It will be the average of the number of tokens or words documents and the number of the students that submit the documents. So the data characteristic that will be detected in the plagiarism is the document may contain the exact replication that is copy and paste from the different resources, and the revised content that is the reverted text and the reorder lines or the logic. And some also detect some the documents may be have a semantically that's similar but have some different vocabularies or the syntax from the different assignment. So for the best worst expected case analysis, for the base case, it will be useful to show the potential of the efficiency for the algorithm under the ideal conditions, no matches or the perfect hashes. In the worst case, it will be illustrate the performance limit of the algorithm. For example, like the LCS, when need to detect the large of the words, it will be used a lot of time because the LCS algorithm need to compare the reorder word that will be used so much time to compare to it. So next to an expected case that is used to show the realistic performance, most of the submission will share same level similarities such as the share reference or the similar word. So the expected case complexity give a realistic performance to estimate. Next, for the time space trade-off, the ragging cat use the low space and fast, but it will be vulnerable to hash if too many the collisions that have to face. And next, for the processing with TF-IDF, that this algorithm will use a high memory and processing time, but it's excellent for paraphrasing. And for the LCS, is precise for structure, but it will be consumes more time and space for a large input, like a document have a 1,000 words of something else. And divide and conquer, it will slide overhead, but it can help to reduce runtime dramatically when scaling the comparison because the divide and conquer can divide the assignment into a small part to let the algorithm to check it more easily. And next, for the process and cooperation management for our group project, that is, and for our group collaboration tools that we use to finish this assignment is using a Google Doc and Canva. So this why we using these two, because this can let us access the same assignment link at anywhere and also can know all our all of our member progress, and we can also inform the group member when he doing the wrong things. And for the task or allocation, we choosing by randomly, and this is our report task that even, and Christopher do the part for introduction and conclusion. Kong Ling Ji do the algorithm selection, me doing the comparative summary and discussion, and Atavan doing the algorithm analysis. And the challenge when we doing the assignment is because we need to choose the suitable algorithm for the plagiarism detection. So we choose many types of algorithm, then we conclude the four types of the algorithm that we using for this assignment. That's all for me. Thanks. Thank you.
So we will look to the recommendations tab. For the overall basic recommendations, for the four algorithms that we are used to determine the plagiarisms inside the assignments, I think the most suitable one is the longest common consequence, subsequence. Reason for choosing the longest common subsequence. Number one, it is a well-defined text comparison tool. It uses the diff tools to show the difference between the files. Second, it is the important tools in the plagiarism detections. It helps detect the common subsequence in the documents. For the correction parts, the importance of these topics with the plagiarism detections in assignments is to find the most suitable algorithms in order to detect the plagiarisms in assignments. Number two, to overcome the plagiarisms issues which is getting serious from day to day in the study areas. The rest of the methodologies is such as number one, try out the four algorithms that already chosen to be used inside the assignments. Number two, choose the best and suitable one between the four algorithms. The key challenge is the efficiencies and scalabilities. Why I say this? Although the most suitable one algorithms has been chosen, but we cannot detect the actual efficiencies and scalabilities when it is actually used inside the school areas. And what will happen? These best cultures will become a new normal inside the schools areas. And the students who wants to take the opportunities will get into the plagiarisms and increase in plagiarisms will increase in the high rates. That's all for us. Thank you for your kind attentions.